Given x equals 5 and x equals negative 2 are zeros of the polynomial function f of x equals x to the fourth minus x cubed minus 18x squared minus 14x plus 20, determine the rest of the zeros. Let's keep track of the zeros below. Again, they gave us two zeros. They gave us x equals 5 and x equals negative 2. Recall the zeros of the x values for which the function value equals 0. Even if they didn't give us the zeros of 5 and negative 2, we could find them by analyzing the graph of the polynomial function. The real zeros appear as x-intercepts of the polynomial function. Let's take a look at the graph. Here we have the graph of the given polynomial function. Notice we have 1, 2, 3, 4 x-intercepts, which indicates all of these zeros are real. They gave us a zero of x equals negative 2, which is the x-intercept negative 2 comma 0. Notice when x is negative 2, the y value or function value is 0. In addition, we have an x-intercept of 5 comma 0. When x is 5, the function value or y value is 0. The other two zeros appear to be irrational based upon the decimal values, which we'll now try to find the exact values of. So going back to our work, because x equals 5 is a zero of the polynomial function, x minus 5 must be a factor of the polynomial, and because x equals negative 2 is a zero, x minus negative 2 or x plus 2 must also be a factor of the polynomial, which indicates we can write f of x as f of x equals the quantity x minus 5 times the quantity x plus 2 times some remaining factor, which would have to be a degree 2 factor. And now let's find this remaining factor by dividing the polynomial by x minus 5 and x plus 2. And we'll use synthetic division. To divide by x minus 5, we use the zero of x equals 5, and then we list the coefficients of the polynomial, which are 1, negative 1, negative 18, negative 14, and positive 20. And now to perform synthetic division, we bring down the 1, multiply by 5, 1 times 5 is 5, and then we add, negative 1 plus 5 is 4, multiply by 5, 4 times 5 is 20, add, negative 18 plus 20 is 2, multiply by 5, 2 times 5 is 10, add, negative 14 plus 10 is negative 4, multiply by 5, negative 4 times 5 is negative 20, add, and we have a remainder of 0, which is what we expect because x minus 5 is a factor. This last line here indicates if we divide the degree 4 polynomial by x minus 5, the remaining factor would be x cubed plus 4x squared plus 2x minus 4. We can now use these coefficients to divide by x plus 2 using the value of x equals negative 2. So we'll go ahead and stack the synthetic division. And again, now use the value of negative 2. To begin, we bring down the 1, multiply by negative 2. 1 times negative 2 is negative 2. Add, which is positive 2. Multiply by negative 2, which is negative 4. Add, which is negative 2. Multiply by negative 2, which is positive 4. Add, and again we have a remainder of 0. This last line represents the remaining quadratic factor, which is x squared plus 2x minus 2. However, this trinomial doesn't factor, and therefore to find the remaining two zeros, we'll have to set x squared plus 2x minus 2 equal to 0 and use the quadratic formula, where we have a, the coefficient of x squared equals 1, b, the coefficient of x is 2, and c, the constant is negative 2. Using the quadratic formula, we have x equals negative b, which is negative 2, plus or minus the square root of b squared minus 4ac, which is the square of 2 minus 4 times 1 times negative 2, all divided by 2 times a, which is 2 times 1. Simplifying, we have negative 2 plus or minus the square root of 4 plus 8, which is 12, all divided by 2. Simplifying the square root of 12, the square root of 12 equals the square root of the product of 4 and 3. The square root of 4 is 2, giving us 2 square root 3. So now we have x equals negative 2 plus or minus 2 square root 3, all divided by 2. And there's two ways to simplify here. We need to be careful. We cannot just simplify the negative 2 and the positive 2 in the denominator. One way to simplify would be to factor the numerator by factoring out 2, giving us 2 times the quantity negative 1 plus or minus square root 3, all divided by 2. In this form, 2 divided by 2 simplifies to 1, and we have negative 1 plus or minus square root 3. The other option would be to write this as two parts, as negative 2 divided by 2 plus or minus 2 square root 3 divided by 2. Simplifying, we have the same result of negative 1 plus or minus square root 3. So now we know the two remaining irrational zeros are x equals negative 1 minus square root 3 and x equals negative 1 plus square root 3. Let's verify the two real irrational zeros by going back to the graph. To verify them, we'll have to get decimal approximations for negative 1 plus or minus square root 3, which I've already done here on the left. Going back to the graph, notice the x-intercept on the far left matches the 0 of negative 1 minus square root 3, and then the remaining x-intercept here does match the value of negative 1 plus square root 3. But again, when doing these types of problems, we cannot use these decimal approximations. We do need to find the exact irrational values. I hope you found this helpful.